Now we're going to start a demonstration video of how to use the Pronto download and analysis software. This is the opening screen that you choose when you get to Pronto. This is where you choose your file that you're going to open up and do your analysis on. Now there is a download process, of course, that you would have to do from the instrument to get it into Pronto. It takes about 11 minutes, and for time constraint purposes we didn't want to put you through an 11-minute wait before we started. However, there are detailed instructions of how to download a Ranger into Pronto on a CD-ROM, on the How to Get Started CD-ROM that is in the case of every instrument that we sell. Once you've opened up Pronto, you're going to want to go to a file and open it up and do your analysis of it. So you would click on File, and then you would go to Open. When you click Open, it opens up the Projects folder underneath Pronto for Windows, and every project that you or your company has saved will appear here. And I'm going to scroll over. These are all project files, and they're called .pdb files. And I'm going to go over here to one called Triam Corporation. I'm going to click on that one and open it up. Now, once you get this opening pop-up here in the middle, we suggest that you make it big because the graphs will reside within the framework that you see here in this pop-up. So I'm going to maximize this window, and now we're looking at the Triam Corporation.pdb file. Now, with Pronto, this connection here happened to be a three-phase, four-wire Y, 480 volts, so that was 277 per phase, 277 volts per phase. And if we choose voltage on channel 1, and we were to graph voltage on channel 1, we go to a 6-step graph wizard here. Now, I'm going to do this with voltage and current, but I wanted to show you something here first. If we just go right to finish, once you've established the 6 steps, which we'll go through one by one shortly, but once you've established the 6 steps, you can go right to finish, and the graph will appear on the screen as you see it here now. At any time when a graph is on the screen, if you just touch the line with your cursor, it tells you the name of the file, the maximum and the minimum and the mean of the values over the entire portion of the recording that you see in the confines of this screen. This is a 1 week long recording. It's 7 days and 1 second long. Now, one thing I wanted you to notice is you'll notice that the minimum here is 0.2, and that's because, and I'm bringing this up to show a typical mistake that a technician will make, is they will start the recording before they hook up the unit. And if you look down this end line here, you see a red on top of the black, and that's because the technician that did this recording started the recording and then clipped on a phase. We advise you to do that beforehand and then start the recording. However, by using the zooming tool, which is the plus magnifying glass here, if you click on that, you get a magnifying glass here, and you can just zoom out the very few first seconds of this recording, and then the voltage will appear as it would normally be presented to your eyes. Now, if I go back to the arrow and pick up my cursor and I touch the screen now, touch the graph line now, you'll notice that the minimum is 246 volts, which is what was the reality of it once it was hooked up. Now, to close out of here, I'm going to go over to the upper right-hand corner here of the screen, not the Pronto program, but of this particular graph screen. I'm going to click to close it, and it's going to ask me, do you want to save changes? And in this case, I'm going to say, no, I do not want to save changes. And it takes me back to my list of data streams. Every data stream is one of the channels that was recorded on the Ranger. Now, we use Windows very well with the Pronto program, and you will see the more you know Windows, the less training you will need on Pronto. For example, I'm going to select voltage on channel 1, and I want to compare that to the current on channel 1. and that current channel is this amps AC on channel 5. I happen to know that's A-phase current. Now if you hold down the control key on your keyboard and then select, it allows you to select non-consecutive data streams by holding down the control key. That is a Windows thing. So I've selected A-phase voltage and A-phase current. If I click on the graph button here on the top, my first step of my graph assistant allows me to change my selections or confirm, in fact, that, yeah, this is what I wanted. I wanted voltage on channel 1 and current on channel 5. That's A-phase voltage and current. I go to my next step. My next step, select the time limits to use on the new graph. If you'll notice, the word playback has a dot in it and is selected. Therefore, I want to look at the entire playback of this 1 week recording. You can see when it started and when it ended. I go to next. Now, here's where you group the traces. In the bottom half of this pop-up is a graph layout. You will always want this to be on tile top to bottom. That's typically the way you want it done, so that time reference lines are all in concert with each other. Now, group traces by, you may want to put all the, if you picked units, all the voltages would appear on one graph, all the currents would appear on another. If you picked data streams, each channel would have its own graph. Project is usually not picked, and all together is the way I want to do this, meaning I want to show the voltage and the current on the same graph grid. And I will say next. The next selection allows you to put a title above the graph and put in horizontal or vertical grid lines, event lines, and various other options that you can do with the legends here. We're going to leave these as the factory sends them because there's another way you can put titles on the graph that is a little easier, and we're going to show you that. If you put the title on the graph at this point, it's going to squish the graph down just a little bit, and the way to keep the graph as big as it can be is to put the title on another way using Windows, and I will show you that shortly. We go to next at this point, and we're going to want to do a line plot. Here you can do a line, average, max, min, or each on separate type traces. We're going to just go with a line plot, the factory default. Here we say next, and here we're doing all auto scaling and formatting. And then we go to finish. Now we've got a graph that's drawn here. The blue that you see is the current loads during the 1 week recording. The red is the voltage during the 1 week recording. You'll notice that on the left hand side you have the voltage scale going from 0 to 300 volts. Remember, it's a 277 volt 3-phase 4-wire Y. And on the right hand side you see the current scale going from 0 to 240 amps. Now, because the technician, if you'll remember, started this recording before he actually hooked up a phase, we have a 0 point down here where you can see a little bit of red. And so what we're going to do is we want to change this scale. We don't want to zoom anything out, but we want to change this scale. Now, you'll notice what you're seeing here, this is Tuesday, the end of the day that we started the recording here. You see a little bit of activity. Then they went home for the night. This is Wednesday, they went home. Thursday, they went home. Friday, they went home. Saturday, Sunday. Now here's where Sunday night some HVAC or something came on, very minor load here. And then Monday morning they came in, worked a little bit extra shift, and then went home and came in Tuesday morning, and the recording ended at the end of the day Tuesday. Now, the bottom or x-axis line of the graph is always time, real time. And you'll notice that these increments here are in months, days, and years. As you zoom in, and we'll do this later, those change. So always look at your legend here to see what your timeline lines of demarcation are. Okay? So the first thing we want to do is we want to get more detail on this voltage graph, so we want to remove this 0 point. So you put your cursor over the scale on the left, which is the voltage scale, and double click it, and now it allows you to change the lower limit to something other than near this 0 point. We're going to change it to, say, 150 volts. And hit enter, and now we see a little more detail in our voltage graph. Now, we're getting some overlap here on the current graph, overlapping onto the voltage graph, which is okay if you have a color printer, but if you're printing on a black and white laser, you want to still be able to see this detail. So we're going to go over here to the current scale on the right hand side. We're going to double click that. And now what we want to do is we want to change this upper limit so that we push down the graph, the current graph, slightly so that there is no overlap here on top of the voltage. So we're going to use the tab key to tab from lower limit to auto to upper limit, which is now at 240 amps, and we're going to change that to 350 amps. And now you can see that we have separated this area here so you can see the voltage dip and the current spike and so on. So everything is separated now, plus we've got a nice empty area in the center of the graph here. We're going to be able to write some text here in a moment that we're going to want to do. Now, remember that we want to title the graph. Whenever you print a graph, and you can print at any point in time, whenever you print a graph, if you have to spend a half an hour explaining to the person you're handing the graph to what the graph is about, then you haven't put enough annotation on the graph. So we would like you to put a title in the graph first. Now to put a title in the graph, you would go up here, and now this is Windows stuff we're talking about here, where this double A is, and that's a line of text, and you click on that, and now your cursor becomes a little I-beam here, and you put it right on top of the graph in the upper left-hand corner here, and left-click once, and it allows you to put a title in the graph. And then you say OK, and now we have a title up here in the upper left-hand corner. We want to make that you can grab this and move it around to position it. We want to make this title a little bit bigger so it looks nice. So we will go to Format, click on Format, and then go to Font. Remember, this is Windows stuff here now. And we want to make the title bold, and let's say we want to make it 18 point, so it's big. And we say OK. And so now we've got a title of the graph that's a nice size right here, and we click off of it, and that's where we would put the title of the graph. Now, another thing we would want to consider is a customer's typical question is well, how long is this graph? Remember, if you touch the line, it tells you the max, min, and average, and so on of the graph. However, what we want to do here at this point is let's go to let me just see here. What we want to do here now is left click once on this line, and it puts what we call handles, these little colored boxes on the line. Once these handles are on the line, you'll notice up here in the toolbar the Greek letter sigma comes out of shadow. If you click on the Greek letter sigma, then you can notice that if you wanted to put the maximum on here, let's say we do, we'll put the maximum of 293.9 volts. Hold down the control key and go to duration. This is 7 days and 1 second. Left click that once. Now after selecting the maximum and the duration of the graph, we say insert, and the Pronto program puts those points on the graph. Now I'm going to click in a blank area here to get rid of the boxes around the two, and you'll notice the maximum is up right where the maximum occurred, and that's right here. And the duration, we're going to take that and we're going to move that over to the right. So now we've got the title on the left and the duration on the right. 7 days and 1 second. And the maximum is 293.9 volts. As a matter of fact, I can move this over just a little bit more, and then I can go up here to the toolbar and grab the line arrow, and I can get a crosshair here now, and I actually will point to the spot and let it go. Come up here and click off, and so I'm actually pointing to the spot where the maximum of 293.9 occurred. Now, the next thing that we want to do is we perhaps want to say something about the graph in here so you don't have to stand there and explain it to the customer. And then when you've printed out the hard copy, he's not required to remember the explanation that you've given him. So here what we want to do is we want to go up here to what is called, it looks like a little sheet of paper, and that's a text box. You click on that, and then you come down here to the center, and you hold down your left mouse button and draw yourself a box that you want the text to appear in. And you let it go. And we're going to put in here that this is a problem. And we're going to click OK. Now, you could type a whole paragraph in here if you wanted to, but I wanted to say that only that this is a problem for the sake of expediency on your demonstration here. We go to Format and Font, because if something's a problem, we want to make it stick out. And here we have bold italic, and let's say we go to 26 point, and let's make it 24 point, and let's make it a different color by coming down here, and we'll make it a fuchsia color, which is a great color on an HP printer. Notice the text is within the confines of the box. After we have it in there, and we click in the blank space to get rid of the little handles, the little square boxes around the text, and we say this is a problem. Well, what is a problem? We go up here to where we have the line arrow. We click on the line arrow, we get that crosshair again, and we hold our left mouse button down and drag and point to that's a problem. That's a problem. You can see what I'm doing here. You can do this as many times as you want. That's a problem, and that's a problem, and maybe that is a problem. So, and then we go up back here and get our cursor back here and click in an area here. And so now we've got a nice graph here that we can print that shows the title of the graph, the maximum voltage that occurred, the time of the graph, and we're stating that there's problems here that we're looking at, and these are not necessarily problems. This is just for example purposes, and we're pointing to areas on the graph that we feel is a problem. This makes for a very nice graph, and then you just click print, and it prints it out exactly like you see it here. Now, if you do not want to have to reconstruct this graph again, you can save it as a .pvw screen, which is like a Pronto view, and then you can just click on it and on the view, and it will reproduce this graph for you instantly with all the annotations. But we're going to click off here now by closing this. It asks us, do we want to save the changes? And this is where you would save the view. We're going to choose not to at this point in time, so we say no. And now we're back to our data streams. Now, another thing that we can do, and we're going to click on a KW graph here to show you this. And this is KW on channel 9. That was the channel that was programmed to be the KW channel. We're going to say we want to graph it. We click on graph, and we go to finish. And here's our KW graph. Very similar looking to the current graph, as it should be, because this is where the load is being imposed on us. Now, here we have Wednesday, Thursday, Friday, Saturday, Sunday, Monday, and Tuesday. Now, you'll notice these are approximately 8-hour shifts that we're looking at here. Remember, this is your real-time timeline down here, this x-axis. So Friday was a relatively light day. There's a big gap in performance here too. The background to this was this was an assembly line where they had a laser welding machine. They had a robot that would pick 2 pieces of metal up, put them on a tool. The tool would index to the workstation where the laser was. The laser would weld the 2 pieces of metal together, and then it would index to a pick station. Another robot would pick off the 1 piece now of the welded 2 pieces and put them on a stack. Every once in a while, what would happen is the robot that picked up the 2 pieces would falter, drop a piece into the tooling. It would delay them for 45 minutes to an hour, or they would have to reset the tooling, and they always had to turn off the power to the entire machine and then turn it back on to reset the microprocessor, because it was getting hit with something that would hang it up, like when your computer gets hung up and the only thing you can do is unplug it and then plug it back in. The same thing was happening to this assembly line, and that's what you see in this gap area here, where a lot less work was being done probably. Now, you'll notice this 8-hour shift on Friday here, they made up for it by going to a 12-hour shift on Monday, which was a very busy day. Now, one of the nice things about the Ranger, and you can use this to check your metering and the billing, is if you just click on this KW graph for the week and put the handles on it. And this could be a week, a day, a month, whatever you wanted it to be. whatever the recording length was. You can click on it like that. And then you go up here to the Greek letter sigma again, which has now come out of shadow. And you click on the sigma, and you'll notice right here it gives you the integration, which is the area below the curve. Remember, this is a rate. This is a demand of kW demand. It's not totalized kW. But right here in the trace statistics, we totalize the total kilowatt hours for the week, and we insert it. And so if you take this, you can move this up at the top, and that's for 1 week. And say we want to put a little text in front of it here to say 1 week. We'll put that right there, and we'll say 1 week. And we'll say 1 week. So 1 week, the integral of this entire week of this assembly line is 3,205.45 kilowatt hours. A customer could take that, multiply that times his rate, and see how much it costs him to operate this line for the week. Now, if we wanted to see how much did it cost to operate for just a day, let's say, we can go up here, grab our plus magnifying glass, and let's zoom in just on Friday. We're zooming in just on Friday. Now we're looking at only Friday's activity. We go up here, grab the cursor, and we click on the graph, put the handles on the graph. We go to the Greek letter sigma, and we look at the integral on the trace statistics here. So the total kilowatt hours to run this assembly line on Friday was 463.6 kilowatt hours. And if you wanted to put Friday in front of that, again, you could go to your text box here, put it right there, and say Friday equals. And we can move that and position it where we want it. And so 1 week was 3,200 kilowatt hours. Friday was just 453. Now, they look kind of lazy here on Friday. Not a lot of work being done when they had a lot of shutdown time, probably because of the problem we discussed on that microprocessor shutting the machine down. So let's go back so we can go to graph. Oops, excuse me. We click on here, put these little handles around the entire graph here. We go to graph, and we go to zoom all, and that would take us back to the beginning. And we're going to zoom in on Monday because Monday looked like a lot more active day than Friday was. And I'm just curious as to how many kilowatt hours they used on Monday, where they got a lot more production out of the line on Monday. We're going to zoom in just on the Monday. We're going to go grab our cursor, click on the line, put the little handles on the line. We have the Greek letter sigma here again. We click on that, and we'll notice that the kilowatt hour usage on Monday was 989.546 kilowatt hours. If you click on that and we insert that in, and so now we have the integration, the area below the curve for the total kilowatt hours used on Monday. And you'll notice that if we put this up here, remember Monday was a much more active day than Friday was, to the point where it was more than twice as much as Friday. And let's go over here to the double A again. Let's pick this Monday. Equals. And say okay, and let's move that up here. So Monday they used 989 kilowatt hours. Friday they only used 453. So they were really working hard Monday to make up for what happened on Friday. Now, one of the very neat things about the Pronto program, it is extremely powerful in that if I was to zoom in, remember this is a manufacturing process. So if you zoom in on a manufacturing process, often what you see, as you can see here, is almost a footprint where the same, or a fingerprint where the same thing happens over, the same thing happens over. A little bit different there, but the same thing happens over, the same thing happens over. This is one part being made, another part being made, another part being made. So what we want to do is just zoom in on one single part being made. One cycle of the machine, in other words, of the manufacturing process. Now, this is one part we're looking at here. If we now click on one part, we put the handles on the one part. Now we go to the Greek letter sigma and the kilowatt hours used. you can actually see, we click on that and we insert it. This is the amount of power required to make a single part. This is the kind of thing that a lot of customers really love because they finally can attach a energy cost to the building of a single part, and that would be 3 kilowatt hours here. It took them to build one part, and here we could put in a title and say 1 BT equals. Say okay, and so at the end of this session here, what we're looking at now, and we'll go back and get the original graph back on here. So here is the kilowatt demand during the 1 week of this assembly line. 1 week's kilowatt hour usage was 3,205. One day, Friday, a light day, was 453. A heavy day, Monday, was 989 kilowatt hours. And to make just one part was 3 kilowatt hours, basically 3.1 kilowatt hours. This is extremely powerful. Now, if you wanted to, you could just click over on your printer icon here and print this. This is very valuable to a manufacturing operation for you to be able to take a look at what's going on. And if you're a utility, you can by doing this, if a customer thinks that they're being billed too high, you can check these readings against your meter readings on the revenue meter, and you will find that the Rangers and the Pronto program are 16-bit A to D converter on the Ranger. It's a 32-bit Pronto program. The data that you're looking at here will be at least as accurate as any metering that you have on there. So you could look at the data for a month or for a week. Just take a meter reading when you start the recording, take a meter reading when you end the recording, and it should match to what you're looking at here. We're going to close out this screen now, and we're not going to save it. We're just going to close it, and we click it here and close. But we could have done more annotation in here if we wanted to, and we'll say no, we don't want to save that. Another capability that Pronto has is to create couple of different reports here because you don't want to just do everything in graphs necessarily. And in order to do that, let's show you here we have what we call the exception filter report. Now, the exception filter report is a very handy report to have because what it allows you to do is to hand a customer a graph and say, here's what your voltage or your current or whatever looks like, and here's an exception report to show how many times that we, the power company, were out of specification or we were not out of specification without the customer having to try and interpret the graph. We're going to create a new exception report here, so we click on New, and we're going to do it, say, on voltage channel 1. We're going to, and this is a 3-step wizard that we get here in this exception report assistant. We're going to say we want to add that to our data streams, which are our recorded channels, to test. Remember, you can pick as many as you want, but for simplicity purposes, we're only going to pick one. And we're going to say, okay, we want to do this test on voltage channel 1. We go to Next, and the second step is, well, where do you select the time limits over which you want to test for exceptions. And I'm going to say I want over the whole week. I want all the data that was downloaded there. So I'm going to say go to my next one. And now, at this point, you get to choose what you want for an upper limit and a lower limit to set as a set point after the recording's been done. This is very nice because you don't have to program a set point into the Ranger when you hook it up to record it. You just hook it up and press start and walk away. Pronto allows you to do all this after the fact. When you specify the set points, it can be outside of limits you specify. That means too high or too low, above and below. Inside, only when you're too high above the set point or only when you're below the minimum set point. We want to know if we're going to put in basically about 5% plus and minus around the 277 volts. And so we want to know if we're too high or too low. So right now we're going to use voltage channel 1. We hit the tab key and we go to our upper limit here, and we're going to put in 290 volts for our upper limit. Remember, this is 277 service. hit the tab key again, and we're going to put in 264 as our lower limit, and we want to check when we're outside these specified limits. And we're going to go down here now and click Finish. And we found the Pronto program found 39 places where the data was outside the limits. In other words, you were out of spec 39 times on this channel. We're going to save the results to a project. And here it allows you to name the project, the exception filter name of this report here. And we're going to say demo test. And we say OK. It rechecks it, and now you can see demo test has appeared. Here are a bunch of other exception filter reports that were done on this before. But we're going to click and highlight demo test, and then we go over here to our preview button and we click on preview, and now it looks to your boss like you spent a lot of time here creating this report. We're going to zoom in on a little bit here, and you're going to see that the exceedance report for the demo test was created on this date, and if it's on, and this is the company name, Triam Corporation. The author, the person doing this I'm doing this on our engineer Jeremy Jungman's computer, and we're calling this the demo test. And here you can see 39 places where you were out of spec, and here's your upper limit set point that we put in, remember, after we did the recording at 290 volts, and the lower limit at 264 volts. We want to test if we're outside the upper or lower limits. Now, what you see here in this first column is the date and time that you went out of spec. In the second column, you see the date and time you came back in spec. In the third column, it shows you how long you were out of spec for in hours, minutes, seconds, and thousandths of a second. You can see the first exception. Remember that we had it at 0 for a while there. So let's scroll down here a little bit. And you can see the biggest offense here appears to be you were out of spec for 1 minute and 8.6 seconds, and you went, and the next column tells you how far past the set point of 290, in this case you went, and you went to 293.9, which is almost 4 volts too high, and it was a maximum, the last column, a maximum limit that was exceeded. This is a very handy report to have, because if you were within spec, it would, during the entire recording, it would say right here, no exceptions found. So if a customer has a complaint that he has low voltage or high voltage, this would either disprove that or would show you the exact instances where it did occur that you were too high or too low on the voltage. And after you, however many, you can do as many channels as you want here. I only did the one channel, as you can see. But you could just go over here and click print, and this will print out very nicely and very quickly on any printer. That's the exceedance or exception filter report. We're going to close this now. Now the other kind of report is an interval report. If we click on reports here, I call this like a demand report, and it's a neat way you can use this report here. We're going to create a new report. There are no reports created at this point. We're going to create a new report, and we get a different 3-step graph wizard here, report wizard, and we're going to go down to the KW channel. This would be the total KW here. It's on channel 9, and in the lower area here, I'm going to say that I want to look at the maximum, the minimum, the time of the max, because remember, this is demand we're looking at, KW demand, and the mean or average and the duration. Whoops, I forgot to hold down my control key and click non-consecutive choices here. Let me do that again. I'm going to hold down my control key, maximum, minimum, time of max, mean, and duration. And let's do the kilowatt hours too, just because we can. So we're asking for 6 columns here in our report on one channel. We're going to add this. Now this moves all this over to the right, and these are the report columns that we're going to be dealing with here. We go to next. We're going to look at all the data again. We want to look at the whole week's worth of KW data. say next. And here, because most utilities in the United States, if they do bill what they call a demand penalty charge or a demand service charge, it's usually on a 15-minute time interval or a 30-minute time interval. We're going to choose a 15 and minutes. Go to minutes here. And so our report columns are going to be 6 across, but their rows are going to be it's going to be a 15-minute average for each row. So we go to finish, and now what you're looking at is a report. This is an Excel style report where we show the date and the time, and these time intervals are every 15 minutes, as you can see. As you go down here, it's every 15 minutes. The next column shows the maximum demand that occurred within that 15-minute period, the minimum demand that occurred within that 15-minute period. And for troubleshooting purposes as to what's causing that maximum demand, we actually timestamp the time of the maximum demand at the heartbeat when it occurred. For example, we had a maximum demand here in this 15-minute period of 123.75 kW. The minimum in that 15 minutes was 14.96 kW, and the maximum occurred exactly at 1900 hours, 2 minutes, and 13.75 seconds. And the mean or average demand was 39.76, and the kW, kilowatt hours, total kilowatt hours used was 9.94. Now, if you scroll down here, this is a very telling report, because if you scroll down here and now we look, you can see that on the 10th of the month at about 6:45 in the morning, somebody came in, turned on the lights, because you had almost no demand before that, and all of a sudden we go from almost no demand to 3.78 kW. So somebody turned on the lights, walked into the building. Then you can see they started heating things up or whatever they did for the manufacturing process. And then at about 7:45, it looks like they started their production. And you can see that at about 10:30, you had over 100 kW demand until about 10:30 in the morning. That was probably, and from until 11 o'clock in the morning. So that's probably early lunchtime or break time or whatever. Then if you continue on down, you can see at 12:15, that 15-minute period, for some reason, maybe a portion of the assembly line went offline for some reason, or they stopped it to retool or reset, and the demand went down to about half. If we scroll down further, you can see that at the end of the day, when they were shutting down, and then they went home. So it's a very telling tale that you can see here through this demand or interval report. And incidentally, if you did this for the whole time period, the kilowatt hours would come out to the same kilowatt hours. If you just put in, I wanted 1 week instead of 15 minutes, it would have just given you one line and told you the total kilowatt hours used for the week. Now, this report, because you may want to do some math on, for example, the kilowatt hour column over here to see if you're being billed or if you're doing your billing properly, you could export this to Excel by going over to File, clicking on File, typing or clicking on Export, and now it asks you to create a file name here, and we would call this Triam, T-R-I-A-M, for the company, and it's going to create a .csv, which is a comma separated variable. And this is a file that any spreadsheet can open up, and then you could then from this spreadsheet multiply this column over here on the right times the rate of your electricity charging to that customer, and you would know how much it cost them to run for whatever period of time. And we just save that here, and it saves it in an exported folder, which later we could open up in Excel, and we would even have all the titles you see here in Pronto would be titled in the Excel spreadsheet for you. Very nice report, very handy. We're going to close this report now. We don't need to save it. I notice it doesn't show that it is saved. Now, we're going to go back to the data streams here because I want to show you one of the features that's available with the new PM7000 and the 7000H and the 7000T. These are 3 models of a PM7000 that will be released in the fall of 2005 that include a feature called waveform capture. This instrument is going to be a very powerful instrument, and typically most instruments nowadays, they have memory on board, like we have 1 meg on our 3000 and 2000. The PM6000 had 4 meg. Some people have a few meg more than that, but the PM7000 is going to have 160 meg of memory in it, and 32 meg of memory is going to be assigned to waveform capture. And that's what you see here that's marked as an AC snapshot. This data was taken with an older Ranger called an HA5000 that did waveform capture. And so we're going to show you how to look at the waveform capture data so that this video may be used once the 7000 is released, because we want you to look at this feature. It's a very powerful feature, as you'll see. We're going to look at the AC snapshot, or transient it will be called, I believe, on the PM7000 of the voltage here. So we're going to select the voltage channel, and we're going to look at some waveform captures now. Once we've selected the voltage channel, we'll go up to graph, click on graph. We can go right to finish now. And what appears is a graph with a bunch of straight vertical lines. Each one of these vertical lines is a 3-cycle waveform capture in this case. With the PM7000, you can make these as big or small as you want, but on this instrument here, all the waveform captures were 3-cycle waveform captures. Now, you can zoom in on one of these waveform captures, or you can go to the graph and zoom here and look at a zoom to AC snapshots. You click on AC snapshots here, and it gives you the list of all the various different AC snapshots. Well, let's start with, say, the third one down here, and we'll say OK. And now we're looking at a 3-cycle waveform capture, and you can see the distortion that occurs here. Now, Pronto makes it very easy for you to move from one waveform capture to the next by just going up here to this command bar up here and just zoom to the next by clicking here. That's the next AC waveform capture. The next, this is kind of a dirty looking one here. Why don't we analyze this waveform capture here? Now, the first thing you want to do is you want to select the waveform capture by clicking on it and putting those little boxes called handles on it. But first, I want to take you up to the top of the screen here, and I want you to show you that the Greek letter sigma and another thing here that looks like harmonic bars are in shadow, and you can't click on them now. That's harmonic analysis. But once you select the waveform capture, and by clicking with the left mouse button once, and you put these little boxes on there, now if you go up here, you'll notice the Greek letter sigma is out of shadow, as well as is the harmonic analysis out of shadow. We're going to click on harmonic analysis because that's what we'd like to do now. Is okay, this is a voltage waveform capture here. Let's look and see what kind of harmonics we're dealing with. We click on that, and now we get a little shaded area here that is exactly 1 cycle long. You can go down to the scroll bar here and you can move it left and right to an area of concern. Well, the dirtiest part of this wave is right here, so that's where we're going to want to go to. We let it go and we say OK. Now we get a 3-step harmonic analysis assistant here, this little wizard. You can check anything here. The first thing I'd like to show you here is where it says show fundamental. We know there's a lot of 60 cycle. If you want to show the fundamental, you would click on that and put a check mark in there. But I choose not to because I really want to get a better look at the harmonics themselves. And if you show the fundamental, there's so much fundamental there, as there should be, it suppresses the view you get of the harmonics. And so I'm going to uncheck show the fundamental, and I'm only going to look through the 1st through 15th harmonic here. You can go up to the 50th with the 7000, but we're just going to say go to the 15th in this view we're going to create. Now, you can do a table harmonics, phasor diagram, bar graph of complex, bar graph of magnitude, but I'd like to do the bar graph of harmonic direction and magnitude. So that's what I've checked here. I go to next, and there's various different views you can give it, a 2D view, a 3D view, but I want to do it as fancy as I can for the purposes of the video here. And so we're going to show a Z-clustered three-dimensional bar graph, and that's what we've checked here. We click next, and it says, do you want to show it on the current view and rearrange it? Meaning, do I want to show the analysis on the one view like you see here, or I just want to dump the actual waveform capture and look at just the harmonic analysis? And that's what I'm going to choose up here, as you can see. So this is what I've clicked. We go to finish, and now what we see is a bar graph of the harmonics. And you'll notice if you're on your scaling here and the magnitude, the percentage of harmonics, we had a fifth harmonic that went almost to 10% here, about 9.5% it looks like. And this was, notice the direction, source to load. So that means that all these harmonics above the zero line here are coming upstream from the point of measurement. There is an 11th harmonic, however, that is pointed down below zero, and so the 11th harmonic is from the load to the source that you see over here, or downstream from the point of measurement. And this is a very powerful tool here, because if you have a customer complaint that states that, well, I'm getting a lot of harmonics, I'm told my motor manufacturer said I'm getting a lot of harmonics or something, if you go up to the service coming to the building and you measure and do a waveform capture, you can then see, and most of the harmonics, if they're current harmonics especially, are going to be coming from the load, because most people cause their own harmonics problems. The power company typically does not generate harmonics. Now, harmonics that do come upstream, or from what we call the source, that does not mean the substation, it means upstream from the point of measurement. Those can be reflected from a neighbor between the customer that you're recording at and the substation. If there's a big manufacturing plant or something in between the substation and the customer you're recording at, you might see them reflecting some voltage or current harmonics down the line towards your customer that would be indicated at the point of recording that those harmonics were coming upstream from the point of measurement or from one of their neighbors. Now, if you'd like to type any information on here, there's not a lot of room to do that, so we suggest that you right-click on this graph and go to Format Chart, and then let's make it real fancy. Now, this is Windows stuff you see here. We'll go to three-dimensional, say, and right now True 3D is off, but let's put it in isometric here, and let's say we want to move this around, like you can move it in either direction. That's a little difficult to look at, so why don't we do it this way? And let me see if we want to do any left to right stuff. I would say probably like this would be good. And you can also change the colors. There's a lot of things that you can do here, but we'll just leave it at that and we'll say OK. And so now we've made more three-dimensional this graph here. You can see the load to source downstream, this 11th harmonic, the source to load, which are all the other ones. Most of them are 2% or less, which are of no consequence, but you do have this fifth harmonic up at almost 10%. But now I've got a little bit of space over here where I could actually write something, and I'll go up here, grab my text box, come down here with the crosshair, hold my left mouse button down, and create a little box here where I can write something. And here I could put, this is a problem, or I could write a whole line of text that I mean a whole paragraph of text here if I wanted to, describing what's going on, and say OK. Again, while we got the handles around the this is a problem, we'll go to Format, Font, Bold, Italic, and we'll make this 24 point, and let's make this one aqua in color. Say OK. So this is a problem. What is a problem? Again, we go to our line arrow, and we can say that this is a problem, and we can say that this is a problem, and then go back, pick up your cursor, click off to get rid of the heads, and there you are. And you can put, you can move this graph around so that you can do whatever you would like as far as description and then print it. Very handy tool, very fancy tool, and it shows you the power that Pronto has available to it as an analysis tool and a reporting tool. We allow you to customize the report yourself so that they mean something and you know what you're discussing with the customer, and because you've actually done the creation of it. And so that is the harmonic analysis portion of Pronto. And we can just close this screen here now by clicking close. We don't really want to save this picture, so we'll say no thank you. We can close this waveform capture screen, and we don't need to save that picture either. And the last thing I'd like to show you, I'm going to go back to a voltage channel here. I want to show you how the legends work on Pronto. We're going to graph this. We'll go right to finish. Now you'll notice, as I stated earlier, you have month, day, and year down here, and you can see 6/13/98. If I go to pick my zooming tool here, my plus magnifying glass here, let's say I want to zoom in. These are right now 1 day increments you're looking at here. Each one of these increments is a day. Let's say I want to zoom in on just a single day. Let's zoom in right here. You hold down your left mouse button, and I'm zooming into 1 day. Now remember, at the bottom, we were annotated in months, days, and years. Here we're going to be, now we're looking at just a 24-hour period here, and you notice now it's changed to days and hours. So you can see that this is the 10th of the month here, 400 hours, 600 hours, 800 hours, 1,000 hours. In other words, we're now down to 2-hour increments. We went from 1 day increments down to 2-hour increments. Now let's zoom in on one of these 2-hour periods. So we're days and hours here now. So now let's zoom in on one of these 2-hour periods. The nice thing is you don't have to actually create the zoom box from top to bottom, just from left to right. And now we're looking at 2-hour increments, and notice now it's changed from days and hours to hours and minutes, you'll notice. So to the left of the colon is the hour, and to the right of the colon is the minutes. So we're at 10:20, 10:30, 10:40, 10:50. So these are 10-minute increments we're looking at here now. So now let's zoom in on one of the 10-minute increments. Now we're still at hours and minutes, but you'll notice they're 1-minute increments that you're looking at here. Now the data begins to look unreal because you're zooming in on it so closely. And so let's zoom in here on 1 minute of a recording. We'll pick this one right here, let's say. And now you'll notice we're at minutes and seconds, and we're looking at 5-second increments here. And you could zoom in even more, and now we're looking at 1/100th of a second increment, and the data looks totally unreal at this point. But my point is that Pronto has the ability to zoom and zoom and zoom. It's the advantage of digital recording, and it's very clear in the legend here exactly what you're looking at, because it always tells you what is to the left of the colon and what is to the right of the colon. Minutes and seconds, hours and minutes, days and hours, or months, days, and years. We can close this out, and we don't need to save it. And this concludes the demonstration of the Pronto for Windows program. If you purchase any of our instrumentation or own any of our instrumentation, we'll be happy to provide you with another CD-ROM that gives a very detailed, even much more detailed than we've gone over here, description of the capabilities and uses of the Pronto program. We want to thank you for your time. We really appreciate your loyalty to the products that we carry. Bye now.